This talk is a first for me in several ways. It's actually the first, I guess it's the first C# 14 talk. Okay, we don't know what we're doing yet, so it's going to be interesting. And so we'll workshop a few things together, and eventually it'll become like the talk that will morph into the .NET Conf talk, I guess. But so far, many things are up in the air, and you can help me design C# 14, because what I throw at you is still in flux. And part of what I really hope to get out of this is to find out what you're interested in and what you think about the things we're doing. It's also the first time I'm on stage with wearing glasses, and I'm finding that it's a little interesting. They're progressives, and how do you do this? How do you kind of? I have screen glasses up here as well, but if I put them on, I can't see you very well, and we'll see how that works out. If I fall off stage, you know why. I didn't actually imbibe anything before the talk. So I do have some of the material that I'm also going to put in my talk for the NDC conference proper. That's about C# 14, but I wanted to make it more freeform today. I can warm you up by showing some things maybe, but I have some web pages open. I have VS and VS Code open for some reason. I have the demo from .NET Conf last year if you want to see some of that, and then some slides. Okay, so we can just move around between those things, and we can't try very much out. I can't do an all demos talk because only a few of the features are actually implemented. I think I have one of them running on my machine. So it's going to be more kind of imagining together. Okay, so I don't know if there's an absolute end time for this.
The building would like us gone by 7 o'clock.
They want us gone by 7. So
the building, if we're not gone by 7 o'clock, they're going to send Jacob a bill.
Okay. Is Jacob in the room right now?
He's left.
Well, it sounds like we have lots of time. So let's be a little mindful of that, I guess. Okay, so roughly an hour. But feel free to interrupt me, shout, raise your hand, and if I don't notice, shout, ask questions relevant to what we're doing while we're doing it, or topics you also want to talk about. Let's try to make it a little interactive, okay? All right. So let's start by. Oh, did I say? Yeah, you said who I am. I forget sometimes. There's a guy up on stage. What's he talking about? I guess it's said in the invite as well. Some of you, maybe you were just crossing on the street and you kind of wandered in. It's a guy talking. Oh, that's something interesting about extensions. You probably want to hear more about that. Let's wait with that a little bit. I want to first, let's just remind ourselves how you can always find out what we're up to. These two web pages. There's one, the Roslyn, they're repos. The Roslyn repos where we implement C# and Visual Basic. There's this feature status page that you can see sorted by version what we're currently working on. So C# 13 we already did, and up here there's the working set for C#, and that is so it's on the implementation page, which means these are features that are currently there's some work ongoing from an implementation point of view. So that's quite a lot if you look at it. Stuff that hasn't shipped yet. And some of these may not make it, or some of them will not make C# 14. But that's like stuff we're currently investing in. Somebody has done some implementation work, okay? So there's what is there, a dozen or so, or 10 at least. And then if you go to the C# Lang repo, that's where we do the language design. There's the proposals folder, and it has a bunch of stuff. These are things that have designs that are not shipped yet also. That are not shipped, but that there's a good chance that we will eventually ship. So you can go find these documents, read more about things, and sure enough, there's There's one here with something with unions. That sounds interesting as well. Dictionary expressions, you might want to see a bit of that today. And then there's extensions. We talked about extensions a lot. We may have almost sort of halfway promised something last year. It was a little embarrassing. We ended up changing our minds. Okay, let's start with extensions then. Okay. All right, any questions so far? Okay. So I'll go to slides for this one. Extensions. So for a very, very, very long time, we had extension methods since C# 3, and approximately since C# 2, we wanted to have extension other things than methods, right? Even way before we shipped extension methods. I've been back, I did some archaeology in our design notes. There are over a decade worth of design notes that are up on GitHub in public that you can all read, and then there's another decade of design notes that I can read that you can't read. Then I went back through all of those from back when we were the Dark Empire, and that's not us anymore. And we always had this problem with extension methods. Oh, extension methods are kind of an easy feature. Extension properties or extension indexers or static extension methods, that kind of stuff. They become very hard, and you can sort of see in the layers of the rock. You can see deposits of various attempts at language design to address that. And I'm going to try to talk about why that's hard and how we totally solved it now. We think, but we haven't shipped it yet, so let's see. So here's an extension method. You can see it's it doesn't even have a body, right? But it's a lot. There's a lot there. It's a select method from link. It takes two type parameters, a source element type and a result element type. Then it takes the special this parameter that's really the receiver. Like you're supposed to call it as an instance method on this thing. And then it takes a lambda to transmograph the input to the output. But it's kind of like it works for extension methods because there's a certain number of things you want to express with an extension method. You want to say that it is an extension method, and you want to say what it applies to, like what's the underlying type. And in order to do that, like the enumerable of t-source here, in order to do that, you also want to maybe take some extra type parameters, in this case t-source. So it so happens that static methods have the ability to pass type parameters. They have the ability to pass parameters, so we can stick all the things in, and there are places to stick everything in already in the syntax. And all we have to add is this keyword to say that it's really an extension method. Okay, so it was an easy hack. But then when you go and say, okay, how do you do extension properties? Well, properties do not have parameters. Should we add parameters to properties now just so we can have extension properties? Probably not. And so we fell off this cliff many times. And this time we decided to address it, and I'm going to talk about how we can possibly do that. So the general idea is take those elements that we need in order to specify the extension part of the deal, fish them out of that syntactic soup, put them together somewhere, and then apply that to what's left, right? So if we fish that out, let's put it in a comment for now, then what's left is really just an instance method. It's the method as it would have been written if it had been a real instance method on the type it applies to, right? And it's no longer static. It only has one of the two type parameters. The other one would have already sat on the type, and it only has one parameter. The other one's the receiver, which would have been implicit because it's an instance method. Okay. But now you can imagine whatever we end up doing with that stuff up in the comment, it now no longer relies on it being a method. Now you can imagine having an extension property instead, right? Whatever stuff we haven't decided on sticking there yet, we haven't decided what it looks like or where to stick it, we could equally apply it to a property or to an indexer or to static members even, right? Now, because the static is gone, now we can put it back and say this is actually a static extension method or in this case, extension property. So you don't call it on an IEnumable, you call it on IEnumable, IEnumable.empty, and you get an empty. That's actually a pretty dumb method. You'll see it again. She probably had a type parameter, I think. Never mind. So you kind of see where we're going, right? Can we lift that out, figure out some good stuff to do with the stuff in the comment? We're golden. So what to do with that? And there are several approaches. We could sort of try to structurally imitate what the extension methods already do, which is to say, let's take all that stuff and glue it onto every extension member. Like, so every extension member in the static class gets to say, oh, I am an extension of IEnumable of tsource, where tsource is a type parameter. I'm also one of those. So I'm on an IEnumable. I'm not. So you can kind of, it's the same amount of information that was in the extension method before, just a little rearranged. Gets kind of wordy. It gets kind of gnarly. And where do you kind of get through the extension soup and are able to tell, is this actually a property or an index or what? Like, is that already off the page somewhere, you know? So it's kind of heavy, but it has some benefits. And so that's one approach. Stick it on the members. The other obvious approach is stick it on the type. So instead of having a static class called enumerable, well, why don't we have a type declaration-like thing called an extension type or something like that? And we stick it on that. So there's enumerable, and that extends IEnumable. And then there's another type, completely separate one, called enumerable of tsource. Luckily, you can overload types on generic arity, so fine. And we put that info on those, including some extension keyword that says, okay, these are extensions. And now inside, you just have those instance members. And that looks kind of nice. But when you start doing it in practice, and this was the road we thought we were on for the longest time, until like sometime last year. Okay, this is going to be great. Then we started looking at what would system.link.enumerable look like if we applied this. What would what's called system.memory.extensions or whatever, what would they all look like? And it actually wasn't great, because it turns out many of those static classes today that have extension methods in them, if they're any guide, they actually have extension methods, or many of them have extension methods for many different underlying types. And they kind of like being grouped together in one type. It's very useful, and you don't have to come up with a gazillion different names you're not really going to use anyway. Oh, this is extensions for int, and this is extensions for bool, and this is, you know. So while this is definitely easier on the eyes in some way, it also wasn't ideal. Now, we thought it would be really cool if they were actually really types, and you could use them as types as well, and it would be worth it. But then we found out, like, pretty much 8 seconds after we presented this idea at Build, that it was infeasible, like, for implementation reasons, to have them really act as types, and we had to give up on that. And then it's like, then is it really so important that they look like types? But so what can you do if it sucks to stick them on the members and it sucks to stick them on the types? Where do you stick them? Okay, so on the C# language design team, we were actually pretty close-minded. So someone from the community came up with the idea that we ended up using, and that is stick them in between. Okay, in between. Have a new layer. So just like extension methods today, there's a static class. You can put whatever you want in there. You can put ordinary static members. You can put old-fashioned extension methods in there, and then they can co-inhabit with these new extension declarations, which group together things that apply to the same underlying type. And they're anonymous. They're just like, here's a group of things that apply to IEnumable. Here's a group of things that apply to IEnumable of tsource. And they can take an extra type parameter if they want to. And then you still have that lovely instance member syntax inside. And that it takes a little getting used to. We don't usually have this kind of like anonymous regions inside of things. But as we work through more and more examples, we felt like this strikes the right balance. It might be that we should have a shorthand where you can, if you have only one extension member for that type, maybe you should be able to stick it directly on the member. If you have only one type for all your extension members, maybe you should be able to stick it on the type. But we can work on that later, like making that look pretty for special cases. In the common case, there's some of each, and this might be the right balance for it. What do you think?
I like it.
Yeah, we like it.
I like it.
Okay, who doesn't like it? Hands up. Yes. Tell me why. You'd rather have the two classes? And the problem, that you'd be fine with having to come up with names, you'd rather? Yeah? Yeah?
It's usually the type of extension.
Yeah. Yeah. Any other thoughts? Yeah.
My thought about it is, I don't mind this, but my problem is, and generally this is something I'm a little bit more worried about with C# in general, is I don't want it to become something like C++, where there's like 100 ways of doing the same thing, and then you have to pick one. Decision fatigue is too much sometimes.
That's really awesome. So don't want to, if you can all hear it for the recording, you don't want to have 100 different ways of doing things. So, and actually, no matter what we do here, we'll end up having two ways of doing extension methods because there's an old way. And we gave up. We actually tried a few times to see if we could, believe it or not, if we could come up with ways of extending the paradigm that matched the old syntax. But yeah, so this will introduce one new way of doing it, but for all kind of extension members. But you're kind of also saying maybe that those like shorthands, that will be too much. And I think that's a good open question. For us, it's often more a case of telling ourselves if we're a bit worried about it, we don't have to do that now. But if it becomes like a common complaint, it sucks for me that I always have to put two layers. Then we can do something similar to like expression-bodied members or something where we say, okay, for this case is very common, we'll give you an alternative syntax that saves you a layer and some curlies and stuff. Yeah, yeah, Denny?
And do it that way for the new things to have extensions on. Will you be able to do also the same thing for the extension methods who are there? So for the methods, instead of having the extension method, so it is right now, doing everything on that way? That's
a great question. So could you take the existing extension methods and rewrite them this way and it would still work the same?
Yes.
Yes. The answer is yes. So part of this is, and we've discussed it a little, whether you should have a specials, you should ask for it specially in syntax or not. I think probably not. That the problem is that today extension methods are static methods. The public static methods, you can just call them as static methods. And so what we will do with these new ones, when they're methods, we will generate those same static methods. We'll guarantee what they look like, and you can do all the same things with them. I think all the same things. There'll probably be some kinks to work through, but that's the intention. So that you can do all this gradually. You can start throwing in extension properties and whatnot next to your old style extension methods in the same static classes if you want. And then you can gradually convert them when you want to the new syntax, and you shouldn't break any of your consumers doing that. That's the plan. Really good question. Oh, here.
Overall, when you have a static class that has static methods inside it, just as a general idea, one of the things I often think about that is, couldn't I have syntactic sugar, which has generated the wrapper static class, so it looked like a standalone method, because F# does that. And in this case, if you did that, you would just basically say, I write extension enumerable source or extension tsource, and you generate a static wrapper class. So therefore, effectively, they would move to top level.
Could you do these as as top level extension members that are just because, or extension groupings here? Yeah.
Offer me anything,
right? So you'd think that the name doesn't offer you anything, and it doesn't maybe offer you much, but we're reluctant to let go of it because if you think about what do I ever use the name for with extension methods today, I use them for disambiguation, or if I want to make sure I really call that the method from that extension versus that one, or things like that, which is pretty rare, but it's not unheard of, and so it's good to have a name to identify it by.
But could you say generally you could just do it like that? The compiler would generate a name for you. If you need to be explicit because you get a conflict, you could then choose to write the more explicit form.
You could say that it's user's choice. Do you have to give it that wrapper and that name or not. But usually it's not the same person who writes the extensions and has the conflict later. So yeah, but it's possible, and it's worth a think. We take it from file name. That would be a little bit of an F-sharpy thing to do, wouldn't it? Yeah.
Swift, as they've evolved the language, they force you to use the new syntax and provide a wizard in the IDE to upgrade previous code. Have you
Excellent.
ever considered, because obviously C#'s quite old, we now have multiple ways, events, and other stuff that are doing the same thing.
This is lovely, and you couldn't hear it over there, but Swift forces you to use an upgrade wizard to go from old language features to new ones, and they just take the old ones away. And I dream of that at night. That would be so lovely. I hate backwards compatibility with a vengeance. Every time I try to design new features, there's always something in the way. There's something really beautiful about that. I really mean that. But at the same time, that would be a very big step for us to do, because everyone's used to and set up to with the expectation that the next version of C# is compatible. We are getting a little bolder with it. We do have breaking changes every time. They're small. We're thinking of doing we're planning to do a slightly bigger one this time around the field keyword. And we just kind of try to push the boundary a little bit, because there are definitely places in the language where a feature became less good because of backwards compatibility that we kind of regret a little bit. Things like, I want to mention discards. How many use discards, like the underscore feature in C#? Yeah, it's not even half. And I don't know why the rest of you don't. Maybe you're just looking it up right now. Oh, it's really hard to search for underscore. But it's actually a great feature, just have a throwaway variable that you don't have to declare. You can just kind of use it and forget about it. But because underscore is also a valid identifier in C#, it only sometimes means discard. It depends on whether you declared it or not and which syntax you use and so on for backwards compatibility reasons, which means it's too hard to reason about. And little seemingly innocent changes in your code can break the meaning of it. And that was all back compat that I wish we had done differently, and maybe one day we can come back and do. Oh man, so many hands. This is going to be great. And I don't even have a timekeeper up here, so you just shout at me when it gets hairy, okay? Danny, sorry, I didn't see which order.
Okay. Am I right that extension is not a keyword yet, so it would be a breaking change because then you will not be able to have a variable name called extension again?
You know, you may be right. We are getting bolder and bolder with that type of breaking change. We've always had contextual keywords in C#, things that only turn blue in the editor if they're in a certain place in the syntax, right? So get and set, they've always been contextual keywords. You would have been, it's kind of surprising that you start V1 of a language and you already have keywords that aren't real keywords, but somehow they decided that, I don't know why. But we can usually, especially if they're in a place where the thing they are likely to get confused with is a type name, then we're like, hey, it's lowercase, you shouldn't have lowercase type names of your own, you know. So, and we have warnings now that say, hey, don't use lowercase names for your types and so on. So we become bolder and bolder around that. When it's in an expression context and so on, it's a little worse because it might refer, and that's where the field keyword becomes interesting, which we may get to, we may want to have a look at, because it's in an expression context, a statement context, where you could have things declared of that name, and now that it's kind of valid or good style to have in lowercase, and now we're making it mean something else. But in this case, given the other stuff around it, I don't know if it's actually a breaking change, but possibly we haven't thought of the right thing yet. Probably if we did the thing where you could remove the static class around it, then it probably would be a breaking change because it could collide with top-level statements or something. But we're not as afraid of breaking changes as we used to be, but we do think about it, and we don't take things away yet. We might take that away at some point. Okay, let's see. I'm sorry, I didn't. We'll take you and then you. And then you.
Why do you extend these style to static classes when allowing you to have like private extension?
Why? Could you say that again?
Why are extension methods always limited to static classes?
Why are they limited to static classes?
Yeah, well, you're saying, why do you need to declare it in a static class?
Is it why do you have to declare it in there?
Yeah.
Because extension methods are like that, and that kind of works okay.
Sometimes you want an extension method very specific to a context, just so that you can get sort of
Yes, so there has been a little bit of a request over the years for like, can you have extension methods declared elsewhere, like inside of a class, of a normal class, where you just want to use it on, you just want it to apply inside of there. And we could, like independently of all of this, we could maybe choose to make that change. We decided to not overhaul too much else around extension methods as part of the same thing here. But that's definitely, that's definitely still something we could do separately. There's no reason, well, there are probably reasons, but I don't know of good reasons yet why we couldn't do it. And then there was one there. Yep.
Yeah, I was going to ask that the customer problem you are trying to solve here is extension properties, right?
Well, extension properties and extension everything else.
That's what I mean, it will become a new syntax for defining extension methods, but along the way you also get extension problems. So the value add for us as C# customers is extension properties, but at the same time you get like multiple ways of doing it. It becomes that you get different syntaxes for the same things.
Yeah.
Basically what we had with the var keyword, and now we have like after
Yes.
the keyword we have the new, which is like two types of writing it exact same thing. So
Two ways of doing the same thing. Yeah.
so what's how do you like think about these things? Because if you like want to have like a uniform code base, I mean it's not optimal to have multiple ways of doing the exact same thing.
That's a very good point, and you can see it took us 15 years to do something about extension properties because we were kind of bothered by first we had trouble just coming up with a syntax that worked, but also we were bothered by having to back out of extension method syntax and go down another route and sort of say that's legacy syntax in a way. We hate having to do that. You might not believe it when you look at C#, but it's something that we do think about and try to avoid. And if we can do something that generalizes an existing syntax instead of introducing a new one, we'd much rather do that. So how do we think about it? Well, we think about it a lot, but if it's necessary and we feel like the value add is enough, and again, it's not just properties. I have, like up here I have properties and methods and indexers, but we could talk more kinds of different extension members as well. There was one over there, and then I'll take you.
Is syntax and the params and the instance names also necessary?
The parens, these parens here, not really, but we wanted to preserve their parameterness. Like in extension methods, these things are parameters, and over the years we've allowed a number of things on them because they're parameters. Like they can have attributes, they can actually be by ref if the underlying type is a value type. So because like if you pass in a struct and it's not by ref, then it's copied, and then an extension method that mutates it's mutating the copy, and so we've added more and more parameter-like semantics that you can choose to use, and we didn't want to take that away. Again, we want to have that continuity. So if we have to let you apply all these parameter-like things to it, let's keep the parameter syntax as well, so it feels more natural. But that was actually a big point of debate for a long time. That's what we landed on. I think I like it. I was very much against it for a long time, and now I'm not.
Could we have the extension keyword as part of the class declaration instead?
Could we have the extension keyword as part of the class declaration? That was sort of like what I showed earlier as one of the options. Let's try to go there. Like this. Yes. That is. well, that was very seriously considered. That was sort of what we were on track to do for a long time. But we found that this ability to group everything together under the same name was important. It's also important if we want to have the thing about being able to express existing extension methods in a compatible way, then this won't work because you lose being able to have the same name for the thing they live in, so you won't be able to have that same disambiguation. So for various reasons like that, and then again also because we couldn't figure out how to make them types. So, but we might let you somehow, for the cases where really all your extension, you only have one of those extension groups inside, we might consider like a shorthand syntax where you can glue them together with the class. Okay, let's take that one and that one, and then we'll go a little further. But
sorry for the solutioneering, but something that is F-sharpy is if you go out to the previous slide, in F-sharp you would have like a default type that's generated for you. If you want to have control of the type, you'd put an attribute on it. So perhaps like there'd be a simple syntax, but like you have an attribute that says, no, I want the name of the generated class to be this thing.
yes.
Very F-sharpy. So
Yes, could you give I mean, it happens here and there in C# as well. So could you give instead of having that whole wrapper thing, could you just give the name of the underlying type in an attribute? Sort of. But you also, where do you put what do you do with the type parameter? You kind of want to declare it and have it in scope across all of them. And again, like an attribute, we probably the recommendation is, yes, do put a name there. You're helping your consumers by putting a name so you can disambiguate. So let's probably have it be through syntax. But I get where you're coming from. And then there was one here, and then I'll move on a little, and then we'll do more hands.
It's a bit of a nitpick, but assuming I only care about providing extensions for static methods, would it be possible to omit the kind of primary constructor syntax? Because obviously the source thing would never be in scope for any of the members of defining it. So it kind of feels redundant in that case.
Yeah, so the question is, if I only have static extension method members, now that we can have that, do I really need that source parameter name there? And the current plan is no, you don't. Like you can omit it. If you don't use it, you can leave it out. You still need the type because you need to say what type it extends. I think we would still have the parens, honestly, but you wouldn't have to say the name. We might even have an unused parameter warning on it if you don't use it in any of the extension members. You can imagine. Okay, so that's kind of the plan. And I know you're not, maybe who writes extension methods? Okay, so you don't just consume them, you write them by and large. Okay, good. Because it is more of a library thing, but it's not just, we're all kind of library authors a little bit, right? Okay, good. That's actually good for me too. I can come home and say, yes, they all do it. They all care about the syntax. Right, so, okay, so we're going down this route, and then what about inside of the bodies? There was more controversy in our discussions here. Like what do you put in? I just had ... on most of the bodies that you saw before. And there were kind of two options for how do you refer to that receiver inside. And what you see here is that what we chose to go with is, we introduced it as a parameter and we use it as a parameter. So that is how you refer to receiver, which means if you're upgrading from a classic static extension method, you can have, the body can look the same, right? But a valid other option would have been use of this keyword, and maybe you could even have an implicit when it's obvious. Like, so it would just be this.any. And kind of, because then it would be similar to, now that we have the declaration syntax be like an instance member, wouldn't it be cool if the syntax in the body was also like an instance member, that it just used the this keyword in the same way? So those two were both very compelling, and we struggled over it a lot. But in the end, we said, okay, we have to be consistent with one thing or another. Let's be consistent with the existing extension methods and use the parameter names. Yes. New slide, new set of hands.
Yeah. You're passing in a primary constructor, a single parameter. Could you not parameterize that as the type itself and then use the this keyword?
Could you as the type, could you parameterize it with the type as like
So on,
system.type or?
in the middle there you've got extension of tsource. Why couldn't it be extension of IEnumerable of tsource? You pass in a double type. What's to stop you passing multiple constructor parameters?
What's to stop you passing multiple constructor parameters? Because it isn't really a primary constructor. And we stop you. The compiler says, nah, you get only one, right? You can only have one receiver. But of course, having a parameter list that always has to be one, it might be a little ridiculous, but it's not the first time in C# that you have a parameter list that can only be one. Like the overloadable not operator, for instance, can only have a parameter list of one. But yeah, I get what you're saying. Yeah, I just don't know what it would mean. Okay, so that's how we chose for the bodies to, like they just continue to refer to it as a parameter. And that again kind of helps because if it's this, then there are weird things with the semantics. Did you know that in an instance member inside of a struct, do you know this is actually by ref? Like it's a ref variable because it has to refer to the thing it was called on, not a copy again, right? And so if you used this, then you might expect the same thing to happen. But if I have to explicitly put ref to get that to happen, then it has one refness, and if I don't, then it has another refness. That doesn't feel right. Like when you're inside of a struct, you can't pick whether this is a ref or not, right? That's not your choice. But also, we want to, I'm not showing it here, but we actually want to be able to, for you to have extension members on a type parameter directly, where the underlying type is a type parameter. You can do that for extension methods today, right? You can say this T, a big T, where T is a type parameter, and then some parameter name. And then you don't know if it's a reference type or a value type maybe. So is this by ref or not? You know, it's just a rat hole. And so we decided, okay, that's a whole different feature. There might be another feature there that's also internally consistent, but for this to be internally consistent, it has to be parameters all the way. Okay, so we might want to talk about other features. Where are we with time, Dylan?
We've got plenty. It's 6:05.
6:05. Good, thank you.
So about half an hour before we need to start calming down.
Before I need to start to talk faster.
Start winding down.
Okay. Yeah, so we saw some member kinds, but there's not really much of a limit as to which kind of extension members you can have. I'm not even showing all the possible ones here. Extension constructors, probably, but they would have to work differently in the body. I don't think, because an extension constructor would really just be a static factory method with a fancy syntax. You can call it with new, so to the user it looks like, but I don't think it should like be able to call a base constructor on the underlying type or something. I think you just want it to create the object itself in a normal method body. So that one will look different in its declaration from a normal constructor. What else do we have here? We have an operator. Why not? Extension operators. One of the things extension methods are used for today is to add methods to specific generic instantiations of types, right? Plus might not make sense in IEnumerable of T, but it might make sense in IEnumerable of int. So the way I can add it to just that one is to do it as an extension member, except you can't have extension operators today, but why shouldn't you? And again, just use the standard. I forgot to put static there, but imagine it says static in front of the operator. No, I did put static, sorry. It's just because I split it across two lines. Yeah, so standard syntax for operator overload. How many people do operator overloads? A few. It's a terrible thing to do, guys. Most people shouldn't do it. But it's nice to be able to, right? There's no reason why not.
Have you seen the example of overloading the division to do string concatenation?
Overload division to do string concatenation?
Yeah, so you can do C/foo/user.
Yes, yeah, it's wonderful. Oh, it's wonderful. This is what makes me believe in the world of tomorrow. What else? Should we have extension implicit and explicit user-defined conversions?
Yes.
It's a bit wild that you can import something and all of a sudden that converts to that.
He is wild.
That's a lame excuse. But on the other hand,
Works for me.
why not? I mean, implicit. Okay, who uses or writes user-defined implicit conversions? Okay, a few, but again, it's very rare. That's because that's also like, it's probably, dangerous. What do you really know what happens when what are all the conversion rules when you user-defined conversions and combine with other conversions on? It's a mess. But sometimes you need it, and then why shouldn't you be able to do it with extension members, right? So the idea here is eventually we have a syntactic approach where eventually we could have all extension members. Now, am I saying that we're going to ship all of the extension members right out of the gate? Yeah, no, I'm not. We'll probably start with methods and properties. The first preview version of it will have methods and properties, instance and static. Right, so the combination of those, the 4 combinations of those, because those are the easiest ones. Maybe indexes will just make it along because they're kind of similar. And then we'll probably go for operators. And that's because those are the ones that we know we have scenarios in our own core libraries that they're just ready to use them. The operators are for the tensor libraries that we're building. So being able to have extension plus operators and stuff on those will be really cool. You can imagine, tensors are like fancy matrices, right? So it'd be cool if you have like that, and then if the stuff inside is stuff that can be added, then you can have an add operator that applies to the outside stuff. It's like the add operator I showed before, right? It makes sense. We'll probably do things gradually. We'll see what the next thing is people ask for, and then over a couple of releases we may have them all, or we may not do them all. I'm not promising anything, but we created the space for it now, so this can finally happen. Okay. All right, done with extensions? Want to talk about something else? What else should we talk about? We could talk about, we go back to, let's have a look at the list. Actually, the list is kind of messy, but we could, we could talk about, do you want to talk about field? Do you want to talk about, let's go to the other list. Collection expressions? Yeah. We already have them. But dictionary expressions, that's new. So some people say unions. Okay, so let me first say we are not doing anything about unions in C#14. The only promise I'm making to you today is that we will not do that in C#14. But we are spending time on unions. That's another thing. I have a single slide that is just for illustration purposes on that topic. Why do people want unions? What are even unions? There are so many possible answers to that, which is part of the reason why we never, many people want unions because F#. And that's been the case for a long time. Like, when are you going to have discriminated unions, like in proper functional programming language? Well, we have inheritance. Isn't that kind of cool? Isn't that right? Well, you don't have exhaustiveness. That's true, and we don't. I know. Sorry, F# users. I'm not implying anything about how you speak. But like a classic functional discriminated union looks like this. And for those of you who are uninitiated, don't know the secret handshake, let's talk about it for just a second. And it doesn't look like this, but something like this. This is what it could look like in C#. Essentially, you say union is either this, this, or this. And all of those cases, they have a name, and that's a tag or a discriminator. It's something that to say and those are all the possible shapes of the value. Okay, so when I have a U, it's either an A or a B and nothing else. So it's different from inheritance in that sense. It's similar to inheritance in the sense that all A's are U's, so to speak, and all B's are U's as well. So it's similar to inheritance, but it stops there. You can't have, other people can't inherit from it. Nuh-uh. This is the full list. And what that gives you is exhaustiveness, which means, and I don't have a sample of that, but it means that when you do pattern matching or something like that, and you've checked for A, you have a U coming in, you check for A, you check for B, then it's not going to say, hey, what if it's something else? You've got to have a default case. It's just going to be, all right, you've done everything. Pattern matching in C# already actually does exhaustiveness checking. It's really good at it, except there are many types where you just don't know if things are exhaustive because you don't have unions, maybe. So that could be one way, and actually the way F# implements it is through inheritance, and then they just have compiler level rules that keep track of the exhaustiveness. So awesome, that could be one way to go, and that's the one we've been asked for decades. I colored the A and B in type color up here, and that's suggestive of something we will do differently probably, regardless of which avenue we pick, than functional languages, which is A and B will be real types for us. They're like actual types. They're not just, the typeness of them is not just an implementation detail. So you don't, like in F# you would have to immediately say, you have to immediately deconstruct A and get that int back out. You can get an A and kind of carry it around for a bit, or dot your way into it, or call a method on it, or something like ungodly like that, something impure. We're like, they can just be types. And if they want to have if they want to be like records and have primary constructors and all of that, fine. And then you can deconstruct them whenever you like. We already got that for types in C#. We don't have to have other things that have to be deconstructed. So unions are going to be unions of types in C#. But they could be types that have to be derived from U and that have an exhaustiveness guarantee. And then when I want to create one, I new up the A. Maybe I have to say U.A, but maybe there's also a feature where I don't have to say that when I'm assigning it to U. I think that would be cool. So that's kind of how that goes. And once you've done a class version of that, then the performance people, they say, oh, we need a struct version, so we don't have to allocate so much. So maybe there's also a struct version of it, although that's harder because then A and B can't inherit from you because structs can't inherit. So that one's probably harder for us to design, but it makes sense, right? We have struct records and class records. Maybe it's the same for unions. And then there's the other end of the spectrum, and more people, when we say unions, they start thinking of it like this instead, where it's not something you declare, man. It's just there. And that's sort of the TypeScript, the approach people know from TypeScript, sort of an algebraic view of unions as just something that you do on the fly to types. Like you can just, it can be an A or it can be a B. Why do I have to give a name to A or B? Why can't it just be A or B? And that's the same as B or A. And if I have a B or A, then it's also an A or C or B because subsetting and like it's all just structural and it's just type expressions, right? And that's also kind of cool. Though it probably gets tedious when the type names are real names with type arguments and so on. But TypeScript works just fine like that. So that's kind of another approach to it. And that we could probably also go down that route, but it's hard how do you do that? Like TypeScript actually the types aren't really there, right? They're only at compile time. And we compile it away, everything's up in the air anyway. Everything can go wrong. The types might have been a lie all along, who knows? Really. But that's not the case generally in .NET. The types are there at runtime as well. When you pass them as a type argument, for instance, they're really there. Like you can ask about them at runtime, you can test against them. And so we would have to find some way for these to be really there. And it turns out in our runtime, it's hard for them both to be really there and also to be equivalent across different permutations of the different types and so on. Like that's just a nightmare. We've explored this very deeply, so it's not just something I'm making up. But we could overcome some of that or live with some edges or something, and that's another approach. There's probably also an approach in the middle where it's like, I don't want this whole inheritance business and the A's and the B's have to inherit from you. I want to be able to combine existing types, but I'm okay declaring them. I'm okay like not having this whole structural business. So that might also be an approach, right? So there's a whole design space here. And many of these could probably actually coexist quite peacefully in C#. Right? That would be many ways of doing the same thing. That'd be awesome. Or not, maybe. The one that we are currently pursuing first to kind of chase a design on is the very first one up there. And that's because that's the one that we haven't run into a problem we don't know how to solve with yet. It's the one that the F# has gone ahead and has an implementation of it, and we can do the same thing and be fine. All the others have problems. Think about the struct version. How would we implement a struct version of this? Well, the simple version is U is really like a record. It's a struct that has a field for both A and B, because we can't just stick them on top of each other, because then things go wrong in the runtime. Then you can't have two different types, especially when they're references are not references on top of each other. So in order for it to work out in practice, we would have to put them next to each other. But then it becomes a really big struct, and big structs suck because structs are passed by value, and so they're copied every time. And most of it would be empty. There would just be one field with something in it, and then a discriminator field somewhere, and maybe that says, oh, it's all in number 3 today. So it doesn't scale very well. And can we then be smart, and can we start crunching it and sharing fields, and all the references go in the same one, and then we type check on the way out, and all the bits go on top of each other over here. And the more we do of that, the slower it gets, and the less you get out of it being a struct in the first place. And so we don't know how to do that one well. If we do end up with a union struct, it's because we've convinced ourselves that when people put the struct keyword, they expect performance and they get performance.
Is F# compatibility a goal in the sense that if I write a library in C# that uses a discriminated union, is there an advantage to the first one that might mean that an F# user will be able to see that as a discriminated type?
Just a second. Oh, talk's over, guys. So F# compatibility. I'll tell you the honest truth about how we do F# compatibility, which is when C# does something first and F# then does it later, then F# very carefully uses the same representation and implementation strategy and so on, so they have max compatibility. When F# does something first and C# does it later, then we do whatever the hell we want, and then F# adapts after the fact to make it kind of work together, adding new syntax if necessary. That was how struct tuples came into F#, for instance, is because in C# we said, we don't want tuples to be reference types, we want them to be this, and then we just did it. So there's a bit of an asymmetry, to be honest, which has to do with, honestly, relative number of developers, and even though F# developers are louder, if you put them all together against all the C# developers, it's still... I do feel a little bad every time, but it is what it is. Sorry. Okay, is that all you have to ask or say about unions? What do you think? What is this? Many people say something. Hands. There. Is the right-hand side what, sorry?
Is it called shapes?
No. No.
Shapes are something different.
Yeah, shapes is not happening right now. Sorry. There.
Yeah. Is it possible to add methods? If you do, I think it would be quite complicated, wouldn't it?
Is it possible to add methods? That's a great question. See, if this is, especially over here, right? Especially on top, if this is really inheritance, why beat around the bush? Why pretend it's something else? Why not just say, hey, this is inheritance. All it is it's fancy syntax, like it's a shorthand. You get a lot of terseness. A lot is implied, like the inheritance and so on. And also you get the exhaustiveness guarantee. But maybe you don't want the terseness, or maybe you don't want all the terseness. Maybe you want to add members to some of these. Well, we don't have to hide from you that it's inheritance. Maybe you can just stick bodies on them. Maybe you can add members to U, maybe you can add members to A, maybe you can add virtual members to U and overwrite them in A. Why not? And because I think there's a whole talk at NDC, which Dylan already said you should buy tickets to, that I have about how we've adopted functional things into C# over the years. But I'm kind of like, I think Scala was the first programming language to really embrace the ideal that you combine object-oriented and functional programming not by having two of everything in the language, not by having like two languages mushed into one, but by trying to unify all the concepts as best you can. And so the more we can unify unions with what's already in C# with object-oriented programming, the better, right? Or am I right about that? That's how I think about it anyway. So if we go that route, let's let you go all out and just treat them as classes. Maybe we even go so far as, maybe we let you slap the union keyword on existing classes, just the way they are, and all that means is, oh, now, and they don't even have any cases, right? You just put the union keyword on there, and then there's some inheritance going on, and all that means is there's an exhaustiveness guarantee. And anyone from outside this compilation or whatever, they can't inherit from it. That maybe we let you, so many people build unions already, they just don't have the language features for it. Maybe we let you just stick something on there, whether it's an attribute or it's a keyword or what, to say, actually, give me exhaustiveness. That's all I want. I don't want the fancy syntax. I don't need that. I just want exhaustiveness. I just want to be able to say, I'm the only one who can add. How many people have been annoyed that somebody else is inheriting from your nice little base class? Right? And you can do tricks like, private constructors and stuff, but what if that was just a language feature? This is my space. I get to do things here. You can't touch it, but you can trust that there are only these things. Hands there, and then there, and then there. Oh, sorry, you've actually been up for a long time. Start with you.
Could we declare the variables like t result of t, and then put generic constraints to say where it's a or b?
Could you?
And then if I want to use it, I have to see if t is a as ta, and then
I can't follow you.
So rather than declaring it as a union, use the generic constraint syntax.
Oh, could you use it like as a syntactic trick? Use generic constraint syntax to.
Yeah, so under the hood I might be returning object.
Right.
But I've declared it as a generic name.
And you just sort of say where it is either A or B.
Yeah.
That could be an alternative syntax for sure. Yeah. I think. And this is totally, by the way, this is totally like just slap it on the wall syntax. Like there's no. It might not end up looking anything like this. So syntactic options are completely open, all on the table. Yes.
Yeah. So on exhaustiveness, and this may be a stupid idea, but I like the idea that you can add a union case and then have the compilation warnings drive the change. So would it be possible to have some sort of way of marking the union so that no one is allowed to have a catch-all? Because what I've seen in the past with unions is sometimes people say, match pattern A, B, and then everything else, well, that must be C. But it's like, then you add a D, you want to be able to say, no, match A, B, and C, but don't assume anything else. Now, if, nested if branches, obviously, don't, but you could get around it.
Okay, yeah. Let me paraphrase for the far corner. So could you make it so that unions, because unions kind of promise that there are only these members, but there's actually I'm not paraphrasing, I'm changing it completely, but I'll probably answer your question in the, but there are actually two kinds of exhaustiveness. It's like there are two kinds of infinity. There's countable and uncountable infinity, and there's probably more, but probably countably many. Because if you think about software evolution, the exhaustiveness in the sort of simple-minded way of it is saying, I will never, it's not just that other people can't add, it's like, I will never add. You can trust me. There will only ever be, red, yellow, and green on this traffic light. And there will never be purple. And sometimes that is really true. But sometimes what you really want to say is, there are only these options for now. You still want, nobody else can add, but I might add later. And so if you have that situation, is there a different contract that you could enforce with the consumers to say, actually, I don't want you to have a catch-all because I want you to get a new warning when I add something new. I don't want you to just assume that the last case was the last case. There might be two in the future. Or maybe the other way around. I don't know. But you could probably, honestly, we haven't thought much about should there be some way to distinguish those two levels of exhaustiveness, if you will. That's an interesting aspect. I feel like there was a hand down there for a long time. That was you? What? Or?
I knew about the question with union and struct. What was the real problem with just occupying the same space, like for example variants? That okay, there will be some discriminator telling what type is underneath, and then blob of bytes, the bigger size of the types.
Yeah. What is it? So what is the problem with occupying the same space? Like it's a trade-off between performance, actually between time performance and space performance. There's a space-time trade-off. They can only become really, the way they become the fastest in terms of like how quickly you can get to the value and is if they're all laid out next to each other. If you start packing it more, then first of all, there are limits as to how much you can pack it because the garbage collector wants to know if there's a reference and in which places are references and so on. So the runtime gets in the way. But also,
I mean, like if the same like variants were, like we can define struct with, for example, 5 fields, and all 5 fields will have the same memory then. And basically doing something like that.
yeah, but that is, so you get more, unless they have exactly the same type, then you get, which in this version they don't, because we said they have different types. But let's say they have the same types inside. Then it matters too much to the runtime what is in a given piece of memory. It needs to know, is that actually a reference? The garbage collector will not let you, will go crazy if you overlap, say, an int with an object reference. And if we So we have to separate those. There are also many optimizations. If we start like saying, oh, there are 128 bits here, I'm going to treat that. Now I'm going to treat it as a long, and now I'm going to treat it as a double, or yeah, So all that kind of reinterpretation of the same bits, it turns off optimization patterns in the runtime. You can't track where things are going. There are many unsafe things about it. So it's just a really difficult thing. I'm not saying we can't do it. I'm just saying it turns out that we will need to work hard on that to become both space and time efficient enough to be worthy of being a syntax in C#. Yeah, we can get, I'm happy to go into more details kind of offline later, but that's the challenge. There and then there.
You've got about 15 minutes.
15 minutes, okay. Let's take those two and then see if there are other things we should also talk about. These are the two most interesting ones, so I'm not unhappy about having spent all the time on them. Yes?
So with your top left example, aren't you 90% there already, where if you've got class U is an abstract class with a private protected constructor, and then A derives from U and it's sealed so you can't overload it. If you do that with A and B, you're basically 90% there already, aren't you, with U, much like in the F# place.
That's a really good point. Like if we had a private constructor, yes, private protected constructor, and actually if they declared inside, private would be enough. But aren't we already protecting? Don't we already have the tools to protect against others inheriting? And the answer is yes, we do. And the last bit sort of is just recognizing that gives us exhaustiveness. And we could indeed, the compiler could probably be smart enough to say, hey, actually, oh, look, they have a private protected constructor. Looks like they're exhaustive.
But can you rely on it? In code which is in another assembly which references it, in this compiler you're doing a match or a switch on it or whatever, you still have to compile it, generate an else clause in case.
Yes.
In case the original code was changed to add another case.
Yes.
So you're always going to have to do that.
That's exactly the question. Can you rely on that? And by having syntax that expresses it as an intent, like I actually intend for this to be exhaustive, then you can rely on it. Like then when the library author puts it there, you're sort of saying to people, hey, rely on it. And then it's a break and change for you to change it later. So that's the difference between kind of just discovering it and then, yes.
How does this feature, how is this design interacting with generics? And like more specifically, can individual case classes use their own generic parameters?
Can individual cases use have their own type parameters? Probably, yeah. Probably, but certainly again, if you're over to the left there, it's so hard to say left while you're waving your right arm. Or for me at least. Imagine like anything you could do with a class hierarchy there in the same structure, we could probably allow it to. There's no reason why not. There's an interesting kind of limitation. There's actually an interesting expressiveness difference between these sides that when you get into generics, which is with this one, if you want to express like a popular example is you have an option union. It's either some or none. And you probably want some to be generic because it could be some int. And that means in order to say some, you kind of want to be able to say option int. So you say, so u is option of int. Option of t. And that means that even the none case has a type parameter. So there's option of int.none and there's option of string.none. And they're not the same thing. Whereas in the structural case, you could totally just say, int or none, right? So you don't have to have that. There's sort of like a structural difference to what you can express. That becomes interesting when you introduce generics. But other than that, I don't think that there are any special differences. So B could introduce a T parameter in its own right.
Yeah, then you would never be able to have exhaustiveness.
You would never be able to what, sorry?
When you patternize against Q, you would never be able to get exhaustiveness because you need to match.
Then you can't get exhaustiveness because you can't match all the B's. Yeah, that's probably true. And that might be a good point to. That's a great point. Great point. Because there's an infinite number of B's. Yeah.
There are ways, but
the B's are dying out, but there's still infinitely many. Okay. I'm wearing my CFAR glasses. Almost said it, but I didn't say it.
Is that time for dictionary expressions?
Want to talk about dictionary expressions?
Yeah.
Okay. Okay. Let's actually just, I think I stuck one in here. Yeah, let's just go have a look in VS Code here. So, collection expressions, yay! You can have elements, you can have spread, and you can have spread elements. Dictionary expressions would also be nice to have, and there are kind of two ways to do them. One is to say that's a new kind of expression with its own syntax, like it's a new kind of delimiter, or you can say let's just let's integrate them into collection expressions, and we decided the latter. So so collection expressions are all about the target type, right? The thing you assign to, the thing you pass it to, that's the thing that decides what gets created and how it gets created. And when that is a collection type, we know what to do. And so we just need to establish when is something a dictionary type. So there are rules for when we consider something a dictionary type, and when the target type is a dictionary type, which that one probably is, then there's a new kind of element you can also have, and that's the thing there with the colon. So that's a key value pair. Not necessarily key value pair as in the key value pair of k, v in the library, but it is a new kind of element that you can have in a collection expression. And what that means is roughly, call the indexer and assign it. Okay, that's what it will probably mean in this case. So syntactically, that's probably it. There are questions about how are they created, that kind of stuff. And that's roughly as complicated as collection expressions. There are three kind of ways that they might be created, essentially. Either they have an attribute, so we do use attributes, that says, here's how this one is created, and it points to a factory method, and that gets called. And then all the elements get poured into something, and it gets passed as a read-only span to the factory method, and things happen. So that's how many of the library types, and in particular many of the immutable types, do both collection expressions and dictionary, with this and dictionary expressions, because you can't mutate them, so you've got to put everything in from the start, and the factory method does that. Then there's a second category, which is certain interfaces are special. For collection, it's all the interfaces that are implemented by arrays. For dictionaries, it's iDictionary and iRead-only dictionary. And for those, even though they are, so if I went, and that's why I put it in here, so that I could actually, if I went and said iDictionary here, then actually if I said read-only dictionary, then it probably has one of those factory methods, and that's what will happen. We'll stick a factory method on there in the core libraries. You could do the same with your types. If it's iDictionary, then it's special, and the compiler decides what concrete type to actually create. And again, that's just like if it's iList or something like that. Same idea. And iRead-only dictionary as well. And then the third category is, let's assume and pretend that dictionaries itself does not have a factory method. Then if the fallback is to do the same as collection initializers, essentially. Except that for dictionaries, instead of calling add multiple times, we call the indexer multiple times, with each element one at a time. So that's the overall story. Now, there's a little more to it because, and this is actually already a little bit of a problem with collection expressions, but it gets worse with the dictionary expressions in terms of how frequently it pops up. With dictionaries, you very often want to have some kind of comparer. Okay? You want to be able to say, actually, compare the keys differently. Sometimes when you create your own dictionary, you pass it as a constructor argument. We don't have any place to put arguments here, but we would really like for you to be able to pass something anyway. But we can't just say, oh, it's constructor arguments, because sometimes, I just told you, sometimes we don't create them with constructors. And so we kind of want a way for you to wire parameters in, at least for comparers. Maybe also for capacities. For the mutable ones, that's really nice for performance. But we're not entirely happy with what we've come up with so far. It's something like, it has to still be inside of the square bracket, so maybe it's width, and then you put the parameter there, and then it's not really, it's a new kind of element that is how you say that the comparer is, I don't know, the, ignore case thing, or whatever. But on the one hand, we want it to be in there, but we also want it to stand out as not being an element, but we also want it to not have 1,000,000 characters. And should it be in the beginning or should it be at the end? Or what does it mean when there's an interface up there? And what does it mean when there's a factory method? And do you have multiple factory methods? Or so there's just a bunch of stuff there. But the main problem is the syntax. I'm not entirely happy with that, but it's the least bad I've seen. I would love somebody to just come up with the and tell it to me free of charge. You have it?
Well, can you not just do a target type new? So new, open bracket, pass that, the thing in the square brackets, iNumerable key value, comma, compare. Like, so as if you've just done a new dictionary.
New. That with stuff, hereinafter known as that with stuff.
And then you compare there.
Compare dot, or whatever what's it called again? Yeah, it's fine. Something, something, something. Yeah, maybe. But now you're calling new, yeah. But maybe that is, I don't know, but the problem is that it already means something. This already means something, though.
Argument evaluation for new now would have to be a thing that doesn't exist.
Yeah.
That you'd have to figure out how to make it exist for long enough to put it in, and then it would never exist again.
Yes.
So you just move the problem.
Yeah, so I get what you're saying. We happen to stumble on something that already is legal and means something else. But that kind of idea, is that like, can we come up with something where it's not? So, yes.
Could you do the with format, but after square brackets?
Let's try it.
We have to wrap up, folks.
Okay. Right now? Or is it a 5-minute warning?
This is a 3-minute warning.
A 3-minute warning. Wow. Okay. So something like here, with a keyword or without it?
Just to say with brackets.
Oh, space with. Oh, like a with expression.
Column, yeah, without the new.
Yeah, with the compare stuff. Oh, maybe. Yeah. Not too bad. Yeah. Send me. So honestly, mads.torgersen@microsoft.com. Think of something, or go to the repo and suggest it. We just like, please give us options here. Is it bad that it comes after, or should does it? I don't know.
Reads nicely.
Yeah. I'll take this one back. I like that. Thank you both. Yeah. Okay.
All right. Folks, thank you, Mads, so much. Really appreciate it.